Question. Prove this by induction. We answer this question. So for n equals 1, the derivative y equals y minus derivative. And this equals y minus x to the power of -1 derivative. And this equals -1 multiply y minus x to the power of -1 minus 1 multiply the derivative of 1 minus x. So this is the chain rule. And this equals -1 multiply 1 minus x to the power of -2 multiply -1. -1 multiply -1 equals 1. So at last, this equals 1 minus x to the power of 2, 1. This is left-hand side. Now check right-hand side. Right-hand side equals 1n is 1. The top is 1. Then bottom is 1 minus x, 1 plus 1. This equals 1 minus x to the power of 2. So the left-hand side equals right-hand side. The result is true for n equals 1. Now assume it is true for n equals k. Now we have the derivative k y dx k. This equals k bottom 1 minus x to the power of k plus 1. Assume this one is true. Then for n equals k plus 1, we have left-hand side equals derivative k plus 1 y dx k plus 1. This equals derivative dx. Here is derivative k y dx k. This equals, we replace this guy with this guy because we assume and this is true. Then we get d dx 1 minus x k plus 1. This equals, we change the form of this guy. So this is derivative dx k multiply 1 minus x to the power of negative k plus 1. Then this equals k multiply negative k plus 1 multiply 1 minus x to the power of negative k plus 1 minus 1 multiply 1 minus x derivative. So this is the chain rule. Then go ahead. This equals k multiply negative k plus 1 multiply 1 minus x to the power of negative k plus 2 multiply -1. So here is -1. Multiply -1 equals 1. So this equals k multiply k plus 1 multiply y minus x negative k plus 2. Now this equals k plus 1 y minus x to the power of k plus 2. This is the left hand side. Now check the right hand side. Right hand side equals, so we just use the k plus 1 to replace n in the original form. So it's k plus 1. And here is y minus x to the power of k plus 1 plus 1. So this equals k plus 1 y minus x to the power of k plus 2. So compare the left hand side and the right hand side. They are equal. So left hand side equals right hand side. The result is true for n equals k plus 1. Then conclusion. The result is true for n equals 1. And if true for n equals k, it is also true for n equals k plus 1. Therefore, the result is true for all n belongs to positive integers by the principle of mathematical induction.